Hello, welcome to the video solutions for Unit 3, Lesson 5, Divide and Conquer. Ready, set, go. So the ready, straightforward, solve for x. So let's use some inverse operations, right? We want to subtract 13 first, reverse order of operations. So that gives us 5x equals to 35. Right, 8 minus 3 is 5, 4 minus 1 is 3. So then we divide both sides by 5. And 35 divided by 5 is 7. So x equals 7. Here we're going to add 8 to start. So that gives us 1/3 x equals 8. Now to undo this 1/3, we can multiply by its reciprocal, 3, or 3 over 1 if you prefer. So 3. So those go away. 8 times 3 is 24. And we can certainly check our answers by plugging them back in. So here, let's add 4 to both sides first. So we get negative 9x equals positive 4. Then we divide by negative 9. So x equals negative 4 over 9. Okay. Here let's add 60. There's a few ways we can do this one because we see it's quadratic, but since x squared is the only x I see, I don't see like an x squared plus x or something. I'm going to add 16 first. So I get x squared equals 16. Now I can use the square root property to take the square root of both sides, but I do have to be really careful. Remember, a positive number squared would give me a positive number, or a negative number squared would give me a positive number. So when we do this, we have to do plus or minus. This could come out to either positive or negative. So the square root of 16 is 4, so that's one option. But the other option would be negative 4. Negative 4 times itself would also be 16. So we have two possible answers for this one. Okay. For this one, x squared plus 4x plus 3, we can try to factor, or we can try the quadratic formula. I always like to test our discriminant, b squared minus 4ac. That's going to tell us if it's factorable. So our a is 1, our b is 4, and our c is 3. So b squared would be 4 squared minus 4 times 1 times 3. So this gives us 16 minus 12, which is 4. Since 4 is a perfect square, this is factorable. So let's go ahead and try to factor it. Now, maybe you notice that factors of 3 that add to 4 are 3 and 1, and you went straight to factoring. X plus 1 times x plus 3 equals 0. Now we can use the zero product property, right? If these are two factors being multiplied that equals 0, that means one of the terms must be 0. So I set each one equal to 0 to solve for that. So I get two answers, x equals negative 1 and x equals negative 3. Those are both possible solutions to this quadratic equation. All right, factors of positive 6 that add to negative 5. Again, be really careful with this when we have that positive 6, but they're adding to a negative in the middle. It needs to be two negative numbers. So again, let's do our b squared minus 4ac and just make sure let's see if it's factorable. So our a is 1, our b is negative 5, and our c is positive 6. So b squared, we get negative 5 squared minus 4 times 1 times 6. So this becomes 25 minus 24. 1 is a perfect square, so this is definitely factorable. So let's think of factors of positive 6 that add to negative 5. Well, negative 2 times negative 3 multiply to positive 6 and add to negative 5. So those are going to be the two numbers I pick. You can also turn this into 4 terms by factoring by grouping. Here we use their zero product property to get x equals 2 and x equals 3. So our answers are positive 2 or positive 3 as possible solutions. And I mentioned that other form of factor and turning it into 4 terms with grouping, right? We could have used that minus 2 and that minus 3 and replaced the minus 5x with it and grouped these terms together. Here, our greatest common factor is x. So we take out x, we're left with x minus 2. Here, we can take out a negative 3, which leaves us x minus 2. Now our greatest common factor is x minus 2, and we're left with an x from our first part and a minus 3 from our second. So we ended up with those same factors, just a little different strategy if you wanted to do an alternative method of factoring. They produce the same answer. Okay, 7, 8, and 9, all three of those are already factored for us. They're equal to 0, which is an important thing to note, because if they're factored but not equal to 0, we can't use the zero product property. So here, we can jump straight to setting them equal to 0. So I move that positive 8 over to get a negative 8. Move this positive 11 over to get a negative 11. So x is negative 8 and negative 11 as our two possible solutions. So here we're getting a little bit more comfortable. I'm going to skip some step here. If I have an x minus 5, a positive 5 would make that product 0. And a positive 7 would make this one 0. So we can skip steps a little bit once we get comfortable. Okay, here let's not skip steps because there's a lot going on here, right? I have 3x minus 18, so I can set that term equal to 0. And then I can add 18 to both sides. So I get 3x equals 18. And to get x by itself, we divide by 3. So I get x equals 6. Now I actually could have factored out a greatest common factor as well and had factored out a 3 from the first set of parentheses and a 5 from the second. But I think because this is already factored, it's just as quick to just go ahead and solve both of these as little linear pieces. So I move the 10 over to make it positive, divide by 5, so I get x equals 2. So my two possible solutions are x equals 6 or x equals 2. Both would be solutions to that quadratic. So that's number 9. Let's jump down to our set questions. So set questions wants us to first divide. So we're going to divide these polynomials. So when I'm dividing, I always really just want to focus on these first leading terms. So how many times does x go into x cubed? Well, it goes in twice. So now off to the side, I'm going to actually multiply x cubed times our x plus 1. Sorry, x squared times x minus x plus 1. So that gives me x squared, x cubed plus x squared. So that's what I'm going to subtract, right? So minus x squared. Now be careful, if we're subtracting all the terms, we have to subtract both of them. So minus, I wrote my square again, minus x squared. So be really careful. So if I'm subtracting this, so the value I'm subtracting is negative x cubed minus x squared because I have to distribute that negative. Okay, so this gives me a minus 4x squared here, and I can pull down the rest. So now we're focusing again on x and negative 4x squared. So if I multiply this by negative 4x, that leading term, negative 4x times x plus 1, that leading term is going to add to 0, right? So I get negative 4x squared minus 4x. Remember, I am subtracting this term, this polynomial. Oh, there we go. Sorry about that. So when I subtract them, I distribute that negative. So I end up really adding 4x squared and adding 4x. So those go away. We're left with 10x here. Pull this 11 down. So plus 10, because x can go into 10x 10 times. So I used a positive 10. So that gives me 10x plus 10. And that's the term I need to subtract. So I'm subtracting 10x plus 10. I keep saying term. Those are the terms I need to subtract. So I minus 10x minus 10. I have a remainder of 1. So I'll put R1 up here. Now it says write only one multiplication statement if the divisor is a factor. Well, this one isn't. We had a remainder. So if there is a remainder, that's us, write the quotient in 2 ways. So one of the ways that we can write it is x plus 1 times this whole thing, right? So x squared minus 4x plus 10 plus 1 over x plus 1. We never actually divided that, so I have to show that it's still dividing. Or another way is we can kind of leave the remainder out. So x plus 1 times x squared minus 4x plus 10, and I'm going to close up my parentheses now, because that's going to give us everything. If that was a 10, right? If that number was a 10, that would work out perfectly, but it's not. We have to make it 11, so I just add my remainder right at the end there. And either one of those would be other ways to represent x cubed minus 3x squared plus 6x plus 11. So that is question 10. Okay, move on to question 11. Question 11 wants us to divide x minus 5. X minus 5, or x cubed minus 9x squared plus 23x minus 15 divided by x minus 5, I should say. So again, let's focus on those first terms. I can have x squared. X squared times x minus 5 is going to cancel out that x cubed term. So this gives us x cubed minus 5x squared. And remember, we always want to be subtracting these terms. So negative x cubed minus 5x squared. So I'm going to switch all the signs. I'm going to do minus x cubed. But that negative 5x squared is going to become plus 5x squared. So negative 9x plus 5x gives us minus 4x squared. Pull down my 23x. Pull down my negative 15. Okay, so now we're looking at x squared still, but now we're using this negative 4x squared. So I need the minus 4 to make the coefficients match. And I need one more x. So negative 4x times x minus 5. That's going to give us negative 4x squared, which is good. That's what we want, plus 20x. So remember, if I'm subtracting those, I have to switch both signs. I distribute my negative. So this becomes a positive 4x squared. And then this negative 20x becomes, this positive 20x becomes a negative 20x. So these cancel out, which is what we want. We are left with 3x there, and we pull down this negative 15. So x can go into that 3x 3 times. So 3 times x minus 5, that gives us 3x minus 15. And remember, we want to subtract that term. We want to subtract 3x minus 15. We want to subtract those terms, I should say. So that gives us minus 3x plus 15, which gives us no remainder, right? So that divided perfectly. So it says write only one multiplication statement if the divisor is a factor. Ours is, so our multiplication statement is x minus 5 times x squared minus 4x plus 3. And you can always multiply to check your work. It never is a bad idea to check by multiplication. Okay, question 12. So this time we have 2x as our leading term in there, and 2x cubed. So the 2's already match up. All we need to do is multiply by x squared here. So x squared times 2x minus 1 gives us 2x cubed minus x squared. Remember, we are subtracting these terms, so we're going to switch the signs. So I'm going to do minus 2x cubed plus x squared. Okay, so these cancel. Here we're left with 16x squared. Pull down our minus 34x and pull down our 13. Okay, so 2x and 16x squared. Well, 2 times 8 is going to give us 16. And to get an x squared, I want one more x. So 8x times 2x minus 1. Let's see what that gives us. That gives us 16x squared minus 8x. So I'm going to switch both of those signs because I want to subtract. So negative 16x squared plus 8x. So our first two terms, our leading coefficients, or leading terms I should say, reduce out, which is exactly what we want. So now we need negative 34 plus 8, or negative 34 plus 8x, gives us negative 26x. And let's pull down that 13. Okay, so negative 26x and 2x. We already have the x's, so we just need to think 2 times what gives us that negative 26, and that would be a negative 13. So let's start with our negative 13 actually. Negative 13 times 2x minus 1 gives us negative 26x plus 13. Remember, we need to subtract that, so I'm going to switch both signs. I'm going to make it a positive 26x and a minus 13. So once again, we have no remainder. So we're only going to write our multiplication statement one way. We're going to write it as 2x minus 1 times x squared plus 8x minus 13. Now I'm doing long division for all of these because that's how this was set up. However, synthetic division would also give you the same answer. So if you want to go ahead and try one with synthetic division, that might be good practice just to try a different method. All right, let's go to problem 13. We have x and x cubed. So that means we need an x squared. So x squared times x plus 4, that gives us x cubed plus 4x squared. And those are the terms we need to subtract. So I'm going to subtract x cubed and subtract 4x squared. Okay, so our first terms, just like we want, go away, which is great. And then 13 minus 4 gives us 9, or 9x squared, I should say. Pull down that 26x and pull down the 25, minus 25. Okay, so x and 9x squared. X goes into 9x squared, 9x times. So let's take our 9x and multiply it by x plus 4. That gives us 9x squared plus 36x. So those are the two terms we're going to subtract. We're going to subtract 9x squared, and we're going to subtract 36x. So we are left with negative 10x, and we pull down negative 25. So 10 goes in, so x goes into negative 10x, negative 10 times. So negative 10 times x plus 4. That's going to give us negative 10x minus 40. And I'm going to subtract both those terms. So I'm going to get 10x plus 40. So we are going to have a remainder here because 25, negative 25 plus 40 does not give us 0, right? So negative 25 plus 40 instead gives us a positive 15. So that is our remainder. Remainder of 15. So we do have to write our multiplication statement in two ways. X plus 4 times x squared plus 9x minus 10. And in that same set of parentheses, I'm going to add 15 over x plus 4 because I did not actually divide those. Or we can leave our 15 out, right? X plus 4 times x squared plus 9x minus 10, right? That would give us everything except for that extra 15 at the end. So I just add 15 so that that last constant number, that negative 25, is actually a negative 25. So there we go. There's question 13. All right, question 14. We're going to divide again. So x goes into x cubed. Let's zoom up so I can be a little neater here. X squared times, right? So x squared times x plus 7 gives us x cubed plus 7x squared. And again, we're subtracting both of those. So I want to subtract x cubed. I want to subtract 7x squared. So negative 8 minus 7 gives us negative 15. Sorry, my pen just wasn't writing for a second there. There we go, negative 15. So I pull down my negative 111x and pull down my 10. So now 7 goes into negative 15x squared, negative 15x times. So we have negative 15 times x plus 7. That's going to give us negative 15x squared. And then 15 times 7, well, 7 times 10 is 70. And then 5 times 7 is 35. So 70 plus 35, we get 105. Now 15 is negative, so negative 105x. Okay, so remember I have to subtract both those terms. So they're both going to turn to positive when I subtract them. So plus 105x. I forgot the x there. There we go. So 105 minus 111, or negative 11 plus 105, is going to give us that negative 6x, and we carry down this 10. So x can go into negative 6x negative 6 times. So negative 6 times x plus 7. That gives us negative 6x minus 42. Okay, so we're going to subtract both those terms. So 6x plus 42, since we're subtracting, and this is going to get us a remainder of 52. Okay, so we're going to write our multiplication statement in two ways. X plus 7 times x squared minus 15x minus 6. And just to show the order doesn't matter, I'm going to close my parentheses and put my 52 outside the parentheses first, because I've been doing it second, just to show the order. Whichever one of these answers you put first doesn't actually matter. One does not take a higher priority over the other. So for this one, positive 52 is my remainder, so plus 52 divided by x plus 7. And then I close out my parentheses. Okay, so that's problem 14. So on to problem 15. So 3x goes into 3x cubed x squared times. So 3x minus 4. Actually, I'll start with my x cubed. So x squared, times 3x minus 4 gives us 3x cubed minus 4x squared. Remember, I want to subtract both of those terms, so I have to switch their signs. So it's minus 3x cubed plus 4x squared. So those go away. 23 plus 4 gives us a 27x squared. And I pull down my remaining terms. So 3 goes into 27 9 times, and x goes into x squared x times. So 9x times 3x minus 4. That gives us 27x squared minus 36x. So again, I have to subtract those, so I switch the signs when I subtract them. So plus 36x. Okay. Let me just clean that up a little bit. 36x. Okay, so our first terms go away, and 6 plus 36 gives us a 42x minus 2. Now 42 goes into 3 13 times. If you don't know that off the top, you can think of 3 times 10 is 30. So I need another 12. Well, 3 times 4 is 12. So 3 times 14 is going to give us 42. So without using a calculator, we can kind of use ones that we do know to help us with ones that we might not know. So plus 14. So 14 times 3x minus 4. So we get 42x minus 14 times 4 is 56. I don't know why I started putting a 2 there. 56. I was thinking 28 times 2 because I was doubling it in my head. So we're going to subtract those. So we're going to do minus 42x and then plus 56. So we get a remainder of 54. And I just realized something didn't feel right about that. That's because I pulled down a 2 instead of a 28. So this is a quick fix. It doesn't change much. So our remainder is not 54. Negative 28 plus 56. Okay. Sorry, paused so I could cough. Anyways, I forget where we left off here, but we haven't subtracted these yet. So 28 is half of 56. So negative 28 plus 56 is positive 28. So that is our remainder. It's a good thing we go back and look. Okay, so we do have a remainder, so we have to write our multiplication in 2 ways. So 3x minus 4 is equal to, or times, x squared plus 9x plus 14 plus a 28 on the outside of the parenthesis, or we can stick that 28 inside as long as we show that it's being divided by our 3x minus 4 still. And there we have it. Okay, so 16, we're finally changing things up a little bit. This time it gives us a function. It wants us to calculate f of negative 1. So let's go ahead and plug in negative 1 everywhere we see an x value. So we have negative 1 cubed minus 3 times negative 1 squared plus 6 times negative 1 plus 11. So negative 1 cubed stays negative 1. But here, we want to make sure we do order of operations correctly, so negative 1 times itself becomes a positive 1. We do that before we multiply by the negative 3. Here, 6 times negative 1, I'll just write that as minus 6. We have a plus 11 at the end. So negative 1 minus 3, 3 times 1, minus 6 plus 11. You can do this in whichever order you choose. Negative 1 minus 3 is negative 4 minus 6. We get negative 10 plus 11. So this whole thing comes out to just a positive 1. So f of negative 1 is positive 1. So there's the answer to 16. Okay, question 17 wants us to go all the way back to problem 10. So it says, how does your answer to problem 16 relate to problem 10? So I just took a little snapshot of our problem 10. So this is problem 10. Right, so problem 10, well, how does it relate to 16? We see x cubed minus 3x squared plus 6x plus 11. Make that a little smaller. There we go. So that is actually the same polynomial that we see right there. So those are the same. So let's think of how this part then, how does this x plus 1 relate to f of negative 1? Well, if I were to solve for an x here, let's do this in purple, I guess. So x plus 1, if I were to solve for x, I get negative 1. So when we have an input of negative 1 here, notice we had a remainder of 1. Well, that was the solution when we plugged in negative 1 into x cubed minus 3x squared plus 6x plus 11. So the result from 16 which was 1, is the same as the remainder. Oh, that's not how you spell remainder. Remainder of problem 10. Right? And those important details, like that the divisor there is x plus 1. So the divisor, x plus 1, and f of negative 1. So that's the same input, really. So we get the same output. That remainder of 1 is our output. Okay. I don't know why I erased that. Let's keep that on there. Okay. Let's go down to problem 18. 18 wants us to calculate g of negative 4. So negative 4 cubed plus 13 times negative 4 squared plus 26 times negative 4 minus 25. So negative 4 cubed, let's do that first. Since we're cubing it, it's going to stay negative. 4 times 4 is 16, and 16 times 4 is negative 64, plus 13. We always want to do our exponents first, so negative 4 squared is positive 16. All right, let's do 26 times negative 4 next. So 26 times 4 is 104 if you want. I like to do 26 times 2 is 52, and then times another 2 we get 104. So negative 104. You can also do it off to the side if you prefer. Okay, so 13 times 16. Well, you can do 10 times 16 is 160, and 3 times 16 is 48, so we end up with 208 there. So negative 64 plus 208 minus 104 minus 25. So you can add it all together if you want, but one thing I notice right away is 104 is half of 208. So I'm going to combine those two, and let's combine 64, or I should say negative 64, and negative 25. So that gives me negative 89 plus 104. You can do this in whatever order you want, though. That's just the order that stood out to me right away. But if I do that, I end up with positive 15. Yeah, positive 15. Okay, so g of negative 4 is positive 15. Okay, so question 19. How does your answer in problem 18 relate to problem 13? So let me grab a snapshot of problem. So here's our work for problem 13. Apologize, I thought I paused the screen so you wouldn't have to watch me go back up and grab a snapshot, but I guess I didn't actually hit pause. So there's question 13. Okay, let me make that a little bit more on the page. So let's do some comparisons. There we go. So we see that we have x plus 4. Let's try to get this all on one screen. There we go. So x plus 4, and we did g minus 4. So again, that 0 that we're talking about here, so the 0 is negative 4, which is what we inputted. So those are the same. And now let's look at, here we have x cubed plus 13x squared plus 26x minus 25. So that is the same as the equation we plugged in. So remember, our answer for this one, for question 18, was positive 15. right? Our answer is 15, and that was what our remainder. So the solution, the result of problem 18 was the same as the remainder. Number, what was that, 13. Number 13, since we have those commonalities, since that we were dividing by x plus 4, and we're inputting negative 4, so we're inputting the 0 from there, and the equation matched the equation we were given as our numerator there. Okay, let's go to question 20. So 20 says input negative 7. So negative 7 cubed minus 8 times negative 7 squared minus 111 times negative 7 plus 10. All right, so negative 7 cubed. This one, I don't expect people to know off the top of their head. So let's do it off to the side. X squared is 49 times 7. So this goes 9 times 7 is 63 with a 6. And then 4 times 7 is 28. 28 plus 6 gives us 34. So negative 343. If you did know that off the top of your head, wonderful. Negative 7 squared, that gives us the positive 49. And then negative 111 times 7 gives us positive 777. Just keep multiplying by 1. Plus 10. 8 times 49. Well, 8 times 50 would be 400. So we just subtract 8 from that to get negative 392. Okay, so if we add all these up together, h of negative 7 equals, well, negative 343 minus 392, what does that give us? 735 plus 777 gives us 42 plus 10, that's going to give us 52. Okay, now how does your answer from problem 20 relate to problem 14? So let's go and scroll up to 14. So we see that in 14, our divisor is x plus 7. And then we have x cubed minus 8x squared minus 111x plus 10. So that's the same as the equation we just used. And notice we got a remainder of 52. So, just like the other ones, our output of h of negative 7. Oh, I just need to plug in my charger 1 second. Sorry for this brief interruption. Okay, the output of h of negative 7 is the same as the remainder from problem number 14. Okay, let's go into the go section now. So, go says solve for x, write your answers as a logarithm, and approximate the answer. So it just wants us to approximate the answer. So let's look at 22. So the first thing I'm going to do is write this as a logarithm. So remember, log form, if I have a to the b equals c, then I can rewrite that as log base a of c equals b. And you can use any variables there. So I'm going to rewrite this as log base 10, which I don't actually have to write the 10. So on my next step, I'll take that away, of 215 equals 4x minus 1. I'm actually going to put my 4x plus 1 on this side. But it doesn't matter. And I don't need to write the 10, so I'll leave the 10 out. Right, so since I wrote the b over here, b equals log base a of c. I just like to have my variable on the left side. So let's solve for x now. We're going to subtract the 1 from both sides. Remember, I cannot subtract into the logarithm. This is closed off, so that just gives me 4x equals log of 215 minus 1. And my last step is to divide everything by 4. So I could leave it like that. So I'm going to come up here. So x equals exactly log of 215 minus 1. I could also make that 1/4 log of 215 minus 1/4 and move that 1/4 up into the exponent of the logarithm, but let's just leave it like this. So now to approximate the answer, we're going to put this in our calculator. And it does say approximate because log of 215 is not going to come out to a nice number. Log of 215 is roughly about I'll write it above, 2.332-ish. So if I subtract 1 from that number, I get about 1. So I'll kind of show that in step. 1.332 over 4. So then when I divide by 4, I get x is roughly 0.3333. We'll go to 3 decimal places. Okay, so that is number 23. I'm just going to make sure we separate these problems really clearly, since my space kind of goes all over the place. Actually, you know what? Let's kind of make those fit a little neater. And then separate. Okay, problem 23. So this one isn't in that like a to the b equals c form. So let's do that first. Let's get rid of this 3 first. So that gives me 10x divided by 5 equals 24. And then let's multiply both sides by 5 to get 10x totally by itself. So multiply both sides by 5. So that's going to give me 10x equals, so 24 times 5, let me think, that's 100 plus 20. So that gives me 120. Okay, so now putting it in log form, I get x equals log base 10 if I want to write it. I didn't write it the last one, so I'll write it this time, of 120. So that's what I can type into my calculator. I know that log of 100 is 2. So this is going to be something slightly over 2. And it is. It is 2.07. Now the next one is 9.1. So let's go to 3 decimal places. I'll stop at 9. 2.079. Okay. And question 24. So question 24, again, it's not in that a to the b equals c form. So I'm going to add 16 to get it there. So add 16 to both sides. So I get 10 to the 7x equals 20. Now I can put it into log form. So I can say 7x equals log base 10 of 20. So my next step then is to divide both sides by 7. So log of 20 divided by 7. Now I know log of 10 is 1. So log of 20 is going to be slightly over 1. So log of 20 gives us about 1.3. Let me fix my approximation signs. Approximately 1.301 divided by 7, which gives us 0.18. We'll go to 3 decimal places, so this is going to round up to 6 because it's 1858. Okay, so that's an approximate answer. There we go for 24. So question 25 is a little different. Given that f of x equals log base 3 of 729x minus log base 3 of 3, select all of the functions equivalent to f of x. Okay, so let's start breaking these down. Let's look at a first. So a, I see I have this log base 3 of x, so it's similar to that. So let's actually separate. Let's use our property to separate this. So let's do log base 3 of 729 plus log base 3 of x minus log base 3 of 3, right? So this is our product property. So, and I don't like the order that I wrote this in. I have my log base 3 of x. We're going to keep that as it is because that matches here. So let's see if when I combine these two, let's kind of use a highlighter to really emphasize what I'm referring to here. When I combine these two, do they give me a positive 5? So let's see. So log base 3 of x. Well, since one is a negative logarithm, I can make these log base 3 of 729 divided by 3. Right, they're both log base 3, and this is question A. I should make sure that's specific. Well, 729 divided by 3, that is going to give us, let me think, 7 goes into 3 2 times. So base 3 of x minus log base 3, that goes in 2 times, and then 4, 3, yeah, 20, there we go, 243. So 243, log base 3 of 243, that actually 243, and we might not know this off the top of our head, but 243 is 3 to the 5th power. So I'm kind of running out of space. I'm going to work down here a little bit more. So I get log base 3 of x minus log base 3 of 3 to the 5th. Well, that is 5. I can bring that 5 down front. Log base 3 of 3 is 1. So log base 3 of x. Oh, and I wrote minus. This should be a plus. Plus log, actually plus 5. We can just write 5 now. So is A equivalent? Yes. So select all the functions that are equivalent. A is equivalent. So let's look at B. I'm going to move A off to the side here as best we can. There's the rest of A. Okay, so there's our A. So let's look at B now. I'll do this in a different color. B. So B. B, I see that I've divided these logarithms, but that is not, the quotient rule doesn't work like that. So I could do log base 3 of 729x divided by 3, but I certainly can't do a log base 3 of 729x divided by log base 3 of x. So no, not equivalent. Okay, so let's move on to C. So C wants a log base 3 of 3x, and there's 2 times log base 3 of 9. So let's focus on what we can really see. So that log base 3 of 3x, that means I want that term. So if I think of 729x divided by 3x, that'll help me figure out like what actually multiplies by 3x to get back to 729. So 729 divided by 3 is 243. We already did that math over here, right? So that math helps us. So I can actually do plus log base 3 of 243. And that is going to give me that 729x back minus log base 3 of 3, because that's the last statement. So now let's think of how we can combine these, right? This gives us log base 3 of 3x, so that part is checked out so far, plus log base 3, I can use the quotient rule, 243 divided by 3 here. Well, 243 divided by 3 gives us 81. So log base 3 of 3x plus log base 3 of 81. Well, 81 I can rewrite as 9 squared. Log base 3 of 9 squared. And then, lastly, I can pull that square in front to do log base 3 of 9 times 2 at the front. So it actually did come out to be exactly the same. This one is equivalent. Okay, and lastly, D. So D, we have, let's lock onto our x term. I think that's a nice one. So this time we have 243. Well, we've already seen this number a few times. So 243, well, let's think 729 divided by 243. That gives us 3. We've been working with that number a lot. So log base 3 of 243x plus log base 3 of 3. That's going to give us that log base 3 of 729x. That's where that's coming from. So then we have minus log base 3 of 3 if we're using this whole statement. So these go away entirely, right? But let's think, is that the same as this? We want to not just simplify. We have that minus log base 3 of 3 already. So we have the first, the last two parts, I should say. So let's just manipulate this plus log base 3 of 3 and see, is this somehow equivalent to 1/2 log base 3 of 9? Well, if I wanted to change my 3 to a 9, right, I can't just change it. But log base 3 of 9 to the 1/2 power, right? The square root of 9 is 3. So I can change it to a 9 as long as I put a 1/2 exponent. That's actually okay. That's still the same statement. That allows me to take that 1/2 and move it in front. So 1/2 log base 3 of 9, that's exactly what I want. So I have the other two terms already. Now I have this one. So yes, that one's equivalent. So A, C, and D are all equivalent, but B is not. And that is the last problem on our Ready, Set, Go homework. So hopefully you found this video helpful. Thank you for watching.